Hi class, today we're going to be learning about simple and compound interest. So to start with the basics, when you're borrowing or investing money, there's always a fee charged to the borrower, and this is what we call interest. And interest can either be paid or could be earned. So when you take out a loan, you're borrowing the money, so therefore you have to pay the interest. But when you're depositing or investing money, you earn interest on your initial investment. And most of this time, this is always coming from the bank. So the simplest form of interest is called simple interest, believe it or not. So how simple interest works is there is a deposit that is made, and it is only made once. And the interest is always going to be applied to the initial amount that is invested. So the equation for simple interest is I equals PRT, where I is the simple interest earned from your investment. P represents the principal amount. This is always going to be a value of money. So that's going to be your initial amount invested. And your interest rate is usually expressed as a percentage, which we convert into a decimal or a fraction. And time is going to be how long that time it's invested. And something to make a note of is that your interest and your interest rate and your time have to be on the same time period. Now, a little acronym for helping you remember this equation is I'm a pretty rockin' teenager, or teacher in my case. Of course, this equation will be given to you, but you can see I equals PRT. It's a little fun way to remember it. Now, if you're looking at interest, that is just the amount earned, right? If you're depositing a money, you're earning it, or if you're paying a loan, then you're paying this interest. But if you ever want to find the total amount of money owed or in your account, you have to add your principal back to that amount. So that's why A represents our total amount is going to be the principal plus your initial investment. So let's just do a few examples with this case. So Michael borrows $2,000 from the bank. The bank charges 11% simple interest per year. So there's your time frame. After 5 years, how much money does Michael owe to the bank in total? So just setting up our equation, I equals PRT. Here, the principal amount is $2,000. The rate is 11%, but again, express it as a decimal or a fraction. And the time is 5, because the rate and the time are matching, we're all set to just plug it into our equation. And when we're done, we can simply just multiply them all together. And we get a total of $1,100. Now this amount just represents the interest that Michael owes the bank, but we want to know how much he owes in total. So one extra little step, we just have to find the total by adding the principal back to the interest that we owe. So in total, Michael owes $3,100. And we'll finish up the sentence, or this question, by writing your conclusion sentence. Now, in our next question, you deposit $600 into an account that earns, again, simple interest. After 2 years, you now have $648 in your account. What is your interest rate? So we have to be careful here when we set up our values. The interest that we made is actually the difference between what is in the accounts. So you actually earned $48 here because we initially deposited $600, but this value of $648 is representing your total, so your A value. So we just had to do a little calculation here to find the interest. And the rate is what we're looking for, and the time is 2 years. So now when we go to our equation Again, with simple interest, as long as you have 3 of the givens, you can always rearrange and isolate for any of the other values. So again, we plug in our information. We do some of our mathematical work here. And eventually we get that R is 0.04, which means that the rate is 4% per year of simple interest. And of course, we'd write a nice conclusion sentence there. So that was simple interest. Now we're going to take a look at compound interest, which actually is the most common type of interest earned. Compound interest is calculated at regular compounding periods. And what this means is that the interest at each compounding period is being added to the initial investment for the following compound period. So what this really means is to calculate this compound interest, we're going to basically be using simple interest earned each compounding period. So it could be each year or each month, and we'll take another look at that. But once you look at that simple interest earned, you add it back to the total, and then that becomes your new principal amount in the following compounding periods. So to get a better idea of this, we're going to look at Alexis, who gets $100 for her 15th birthday, and she's going to deposit it into an account that earns 5% interest, but now it's being compounded annually. As soon as you see that word compounding, that is your clue that it is compound interest. So how we calculate how much is in her bank account after 3 years, we're going to start with $100, and using our simple interest, we find out that she makes $5 of interest in that first year, which means that her final balance in her account is now $105. So that means that next year, she now starts with $105 because it's being compounded. Another way to think of that, remember, is that interest is being added and creating a new principal amount. So now when we calculate the simple interest earned that year, notice that now she's making more interest, and that is because her principal increased. So her total in her account after 2 years is $110.25, and that becomes our new principal amount. So when we calculate how much she has in her account next year, we're taking that new principal amount, earning 5% for 1 year, and we get $5 and approximately 51 cents. So her new total is going to be $110.25 plus that new interest, so $115.76. Now, if we were going to compare this amount of simple interest earned to Bridget, her twin sister, who just deposited into a simple interest account, what that looks like is we're only depositing that $100. We're only doing that deposit once, and we're doing it at 5% for a total of 3 years. So Bridget only earns $15 of interest, which means her total in her account is 100 plus 15. So she only has 115. So clearly we can see that Alexis earns only a little bit more, but if we continue going, Alexis' interest will be much larger than her twin sister, Bridget. Now let's take a look at the compound interest formula. To calculate the compound interest, it is A equals P times 1 plus I to the power of n, where A, like we saw before, is the total balance, P is the principal, but here we now use I to represent the interest rate rather than R, and n is that compounding period. So it's going to be the number of times it's being compounding within the same time period as I. Now, we can also rewrite this equation just using different value variables. So A is also the same as future value because technically this amount is a future amount that you will have in your account. PV is just another way to say what is your present value that you're investing. Well, that represents your principal that you're investing. Notice that I and N also just stay the same. Something interesting to note about both of these equations, though, is when you're calculating compound interest, notice that you get the total rather than the interest. So for you to figure out actually the interest that you earn, you have to subtract your total minus the amount that you initially invested. Or another way to think about that is your future value minus your present value. Now, the other interesting thing to notice about this equation is that both of the equations representing the compound interest are actually exponential, and that is because the n is repeatedly multiplying the base. So in fact, this is actually always going to be exponential growth, and the reason why is because of that 1 plus I to the n will always make sure that it is a value bigger than 1. And what that 1 is technically doing is making sure that you're maintaining at least the full present value, so 100% of that principal or present value amount, plus your additional percentage that you get by adding the I, the interest rate. Now, between these two equations, I do prefer you to use the PV and FV equation, just because those are values that we are going to be using in our future lesson. So it's good to get used to those. And this last equation here is just rearranging for the present value. So both equations will be given to you to be able to either solve for that future value, present value, but you will also be needing to isolate and rearrange the equation for both I and n. Now I'd like you to watch the next video where we walk through some examples.